In this video, I will discuss some of the basic elements of benefit cost analysis, specifically in the context of infrastructure assets such as road or rail elements. I will specifically discuss the incremental benefit cost ratio method and the net present value method. Note that this video assumes that you understand the way that benefit is calculated for infrastructure assets where there is no direct income involved. If you do not yet understand how benefit is calculated for these classes of assets, please look at the other video in the series dealing specifically with this topic. I will leave a link to that video in the description below this video. Before we delve into details, remember that in JunoViewer there are two core processes involved in the optimization of treatments. First, there is the consideration of alternatives on each specific modeling segment to determine the best viable treatment to place on that segment. Second, we need to scan the list of treatments or projects selected in the first step and choose the optimal combination of projects subject to the constraints of our budget and specific network conditions. So in this video, we are specifically interested in the first process, in which we are looking to apply benefit cost analysis principles to select the best treatment option for each modeling segment. For example, here you can see the model is considering the condition of segment 4. Now, if you are using one of JunoViewer's models that are based on benefit cost analysis principles, then the model may generate a set of different treatment options, such as those shown here. Let's look at how we can use benefit cost analysis principles to pick an optimal treatment amongst this set of options. So let's say we have this set of treatment options. Then we can calculate for each option the total discounted present value of costs. Next, we can compare the costs of use and maintenance to a do-nothing option to calculate the benefit associated with each option. This was explained in detail in an earlier video. So here you can see the benefit and the cost discounted over the modeling period has been calculated. Once we have the costs and benefit quantified, we can calculate the benefit cost ratio and also the NPV, or net present value, where the net present value is simply the discounted benefit minus the discounted cost. Now we are finally ready to look into the techniques for picking the best option amongst the ones shown here. We will look at two of the most popular benefit cost analysis parameters used for evaluating projects on engineering infrastructure. These are the Incremental Benefit Cost Ratio, or IBCR, and the net present value method. The steps in the IBCR are quite simple. 1, we rank all the treatment options in terms of increasing costs discounted over the modeling period. Then we start with the lowest ranked option, let's call this option 1, and compare it to the next option, option 2, by calculating the incremental benefit cost ratio as the benefit of option 2, that is the next most expensive option, minus the benefit of option 1, divided by the cost of option 2 minus the cost of option 1. If the calculated IBCR is greater than 1, then we discard option 1 and compare option 3 with option 2 in the same manner as before. If the IBCR is less than 1, then we discard option 2 and we now compare the next option, option 3, again with option 1. And we continue this process until all options have been considered and the best option then is the last one selected. Let's do a worked example in Excel. In this example, I will also show the net present value method and demonstrate that it gives the same result as the incremental benefit cost ratio method. So here in Excel, I have created 10 different projects, each with a different benefit cost ratio based on the benefits and the costs, which we assume are discounted values, and I have calculated the net present value, which is simply the benefit, discounted benefit minus the discounted cost. And I can actually just go and replace this with a formula. and you can see that is basically how the NPV is calculated. The benefit cost ratio is basically just the benefit divided by the cost. Alright, and you can see in this graph over here, I have plotted each of these 10 options, A to J, and I have shown the discounted total cost on the x-axis and the discounted total benefit on the y-axis. Okay, let's go through the steps of the incremental benefit cost ratio method. The first thing I'm going to do, as the method stated, is to rank these projects in terms of increasing costs. So I just go to the data menu and I go and sort these projects on the cost with the smallest to largest. Right, now that I have that, I'm going to add a column here for incremental benefit cost ratio. And recall that I'm going to compare the least expensive option with the next least expensive option. So I'm going to compare option E with option F. So basically I'm going to say equals benefit of this one minus the benefit of the least expensive one divided by the cost of this one minus the cost of the least expensive one. And that gives me the incremental benefit cost ratio. And you can see in this case, this value is bigger than 1. So now I can discard this option, and this becomes my next best option which I'm going to consider. So I've discarded F and I moved on to E. Now I'm going to compare E with D. So I do that with using exactly the same formula, so I can just copy my formula down. But you can see in this case the incremental benefit cost ratio is minus 44. Since it is a negative, I can discount this project or I can reject it. I'm not going to consider it. So I'm just going to color that in yellow. So that one is discounted. And now what I want to do is to actually move my formula on one value, so that now I'm going to compare this project's benefit with the last winner, which is this one here, project E. And the same, I'm going to do the same calculation with the cost. And that gives me a 12. So J now becomes my best value because the incremental benefit cost ratio is bigger than 1. So now I'm ready to compare J, which is my current best project, with the next one, which is I. So I'm going to again put in my formula equals this benefit minus that benefit divided by I cost minus the cost of J. And in this case you can see it's got a negative incremental benefit cost ratio, and therefore I'm also going to discard this project. Now I'm going to move on to the next one in terms of ranked cost, which is C. And once again, if I calculate that compared to the last winner, which is J, it gives me a minus. So once again, this project I can reject. And then I'm going to look at the next project in terms of our rank cost is A, and I'm going to compare A then to the last winner, which was J. So I'm going to compare the benefit of A minus the benefit of J divided by the cost of A minus the cost of J. And that gives me a value of 4. Since it's positive, this now becomes my next winner, and I can now compare A to H and B and G. So comparing this in the same way as before, gives me a negative, and so this project also is going to be rejected. Now I can compare B with A in the same way. I know this is like watching paint dry, but it does help to retype these formulas over and over to really get the understanding under the belt of what Unoveo does when it calculates this increment cost benefit ratio. So here I can also discard this project because the ratio again is negative, and now I'm going to compare G with A. And you can see because this is a negative slope, it's basically going to discard this project as well. And I can just demonstrate that quickly by one last calculation. And that is also rejected because it's got a negative benefit cost ratio. Incremental benefit cost ratio. So you can see that based on this methodology, my optimal project to be selected is going to be A, in this case using this methodology. And you can see that it basically gives exactly the same value as the project with a maximum net present value, right? And note that the project that has the optimal incremental benefit cost ratio does not necessarily have the maximum benefit cost ratio. In this case, the maximum benefit cost ratio is this 8.4 value. However, project A has been selected. And for a long time, I've struggled to find a good explanation of why the incremental benefit cost ratio is used, and why do you not simply choose the project with the highest benefit cost ratio. And I found by looking through the literature and also working through this methodology and with our team when we were programming it, that essentially the benefit cost ratio on its own will tend to favor projects with smaller costs. And therefore it doesn't necessarily look at what you can optimally invest to get a bigger benefit for the budget that you have available. However, it is interesting that the net present value is mathematically actually the same. It's going to always give the same answer as the incremental benefit cost ratio, as you can see here, with this value being the maximum net present value amongst this list. So because you are going to rank this set of candidates in terms of cost, before you can even start running the algorithm to calculate the incremental benefit cost ratio, you may as well rank it on NPV and just pick the maximum or the last one in the list. So in terms of algorithm and running speed, I would much prefer at this stage at least the net present value over the benefit cost ratio. One reference that I did find in the literature said that although the net present value is the same as the incremental benefit cost ratio in terms of selecting projects, the incremental benefit cost ratio does provide some insights about the differences between the projects. So that's perhaps one reason why you may want to consider that method. Otherwise, it seems to me like a lot of complexity which is actually unnecessary. You may as well use the net present value approach. So I hope this overview was useful to you. Based on this video and also the one explaining how benefit is calculated, you should now have a good grasp of the principles involved in Unoveo's benefit cost analysis models. Note that the use of benefit cost analysis is not always practical or optimal, and in some cases a more practical engineering assessment may give better results. We will look at alternative approaches and also those advantages and disadvantages in other videos in this series. Specifically, look out for the video dealing with how we can implement machine learning to pick an optimal treatment based on decisions that have been made before in our field inspections or ForwardWorks program validations. If you have any questions or constructive comments on this video or topic, or if you would just like to learn more about Unoveo's powerful modeling framework, then email us today at info@lonrix.com. Thanks for watching.